G'day and welcome back. Today I want to talk about science. And you're thinking, well, what the heck does that have to do with horses? Well, actually, a fair bit. You see, it's kind of a couple of things here that inspire this. The world has become rather polarized in opinions of, there's people that think science is everything, and then there's also those that, well, they don't believe science is good for anything. Well, I'm pretty much in the middle somewhere. I'll explain about that a little bit. You see, I do have a very healthy skepticism of science. And I'll explain that in a second, but not long ago, well, actually a few times, I've had people make comments about, due to my skepticism, I'd say something about, well, I'm not sure that's all that scientific or something, and they'd say, oh, you don't believe in science. Not true at all. Actually, I'm quite a fan of science. I think science is a wonderful thing. It has certainly taught us an awful lot about the horse. And this is where I think, science and horses go together, is we have learned an awful lot about the behavior and the anatomy and the health and, everything from hoof care to diet to behavior, you name it. I mean, science has provided us with marvelous tools to diagnose the horse from a veterinary standpoint. We got our sonograms, our radiographs, and all kinds of neat stuff, and blood tests and stuff that all provided by science. Science is a marvelous thing. Don't ever think I discredit science, not at all. No, I think science is wonderful. In fact, sometimes it's downright cool and interesting. But science can be wrong. And this is what I want to talk about. There's good science and bad science. And, well, one of the reasons that I am so skeptical of science is, I was taught that by my science teacher. Now, many years ago, my science class, I actually had a very good teacher. I didn't become skeptical because I had a bad teacher. No, quite the contrary. He was a very good teacher. And he taught us, the entire class, to be skeptical of science and how science can be skewed to say whatever you want it to say, depending on the outcome you want. And what he did was he actually took a totally legit, study of some kind and took the data from that study, and they used it to say two completely different things. He came up with two completely different conclusions based on that data. And he showed us how, if you're biased in any way, you can make science say whatever you want. Science isn't always a pure thing. Well, that goes into my next part, is I want to talk about good science and bad science, and three of the things that make up good science. There are three factors. The purest form of science is where you have no bias whatsoever going into the experiment or group study or whatever it is. You have no bias, no preconceived notions. And one of the flaws of science is that a lot of people go into experiments and studies and such with an attempt to prove or disprove a theory. Now, that's a very common thing in science. But unfortunately, that theory produces a bias that, that is one of the things that doesn't make good science, is if you've got a preconceived notion of something you're looking for in the first place when you start to do your study. You don't want that. You want a completely open mind, willing to accept whatever information you end up with in the end. Now, that's the one thing. The other earmark of very good science is control of your variables. Every influence, anything that could possibly influence the outcome of your study or research or experiment or whatever, you want to have control of that, or at least somehow account for it. That's another really good earmark of good science. And the third trait of good science is your sample size, either your study group or the sample that's being analyzed, whatever it is. Very important to get any kind of results that mean anything. Now, for example, on that one is if I wanted to know what the earth was made out of, and I went out in my backyard and I scooped up a spoonful and took it and had it analyzed and said, that's what the world's made out of. That wouldn't be even close to being anywhere representative, because it could easily be contaminated by fluids leaked from my car. It might be somebody's old burn pit, or who knows, it could easily be contaminated by anything. or it could be just an area that has an awful lot of one particular thing in it that is not even close to being representative of the rest of the world. Now, if I was to go out and take samples, deep core samples, 3,000 feet from 100 different places throughout the world, you're going to think, okay, now we got something happening here. We got something much more representative. True, it would be more representative. So we would end up with a sample that is much more representative, but still, well, if you consider the size of the Earth and how deep it is and everything, and we don't actually even know what's in the core of it. We assume it's some kind of a molten mess. Don't know exactly what, but and then we wouldn't end up with samples from the depths of the ocean. But we could also rephrase things to say that, well, what we have discovered is the average composition of the Earth on land masses within the first 3,000 feet of the surface. Well, that'd be fairly accurate. Now we can get to ridiculous science, which isn't science at all as far as I'm concerned, and a lot of that is where you're going to find it, in advertising and that sort of thing. Is that, well, studies have shown that if you use brand X toothpaste, your cavities will be reduced by 68%. What they neglect to tell you is that even if you weren't using toothpaste at all, simply brushing your teeth will reduce your cavities by 65%. Now, another example I'll use is 100% of all criminals have, prior to their criminal activity, consumed water. So it would be safe to say that water causes criminals. Now, I really hope you don't believe that, because that is absolutely absurd, because there's so many other variables there that are not accounted for. But hey, one of the earmarks of good science, I've been told, is that the experiment has to be repeatable. You have to get the exact same results. Well, you could repeat that one as many times as you want, and you're still going to come up with 100%. So that's yet another example of how absurd science can be. And some people will throw in the word science just to make themselves sound good, give themselves credibility. Science, my opinion on something is based on scientific fact. Well, they don't bother to tell you what those facts are, where they got them, or anything else. And in fact, the only reason they're throwing that word science in is to give themselves credibility, and so that you'll believe their opinion. And that is not always the right thing to be doing. So a lot of studies that I have come across, some actually give you a reason to think about things, but many of them, if you look at them with a critical eye, you realize there was an awful lot of variables that did not take into account, and a lot of things that could have been done differently. Their section was way too small, and things like that. And I just don't jump on the bandwagon and say, okay, science says such and such, so I'm going to believe it. Sorry, it just does not work that way. I'm not going to just buy it because somebody throws that word science in there. And that's why I have this, skepticism of science, because it's not always science, or it's not always good science. So, like I've said many times in other videos, is be careful what you believe, because in some cases it can get you hurt. So, when somebody says science, think twice, look carefully. Don't just jump on it because science says so, because there's also been many cases where science itself has proven science wrong years down the road. So be critical about things, look at them closely, consider the facts, and look at the big picture, how big the sample is and all that stuff. And science isn't always bad, but not always right either. Okay, be careful. Have a good day.